Hi, today I'm going to go over types of symmetry and also identifying transformations on a grid. So the first question says, what type of symmetry is shown in the image below? And we've got this arrow figure here. Well, we have three types of symmetry. The first I want to discuss is reflectional symmetry. That means that if I draw a line of symmetry, half of the shape is reflected exactly the same on the other side of that line of symmetry. So if you notice here, this vertical line down the figure, the left side of the arrow shape matches the right side of the arrow shape. They are reflections of each other. So there's vertical reflectional symmetry here. There's also a horizontal line of symmetry. You can tell the top part of the arrow figure matches the bottom part of the arrow figure. So we can automatically say that there is reflectional symmetry. The next two types are rotational and point symmetry. Point symmetry is a type of rotational symmetry. Point symmetry is 180-degree rotational symmetry, meaning if I pick a center point and I rotate the figure 180 degrees, the figure will look the same turned upside down as it does right side up. So I'm going to go ahead and rotate this arrow figure. Here's my center point, and it rotates. And right now, at that split second there, it was exactly the same upside down as it was right side up. So I can tell that it has point symmetry. If it has point symmetry, since that is 180-degree rotational, we can also assume that it has rotational symmetry. Rotational symmetry is just any rotation of any degree where the shape looks the same after being turned as it does originally. And the only rotational symmetry this one has is the 180-degree point symmetry, but sometimes other shapes can just be turned 90 degrees and they still look the same, like a square, or 270 degrees. And so rotational symmetry also accounts for those other degrees of rotational symmetry that the 180-degree point symmetry doesn't account for. So for this one, I can say that all three of these types of symmetry are shown in this image. All right, and then my next slide, identifying transformation types. Sometimes you will have an original image, the pre-image, and then the image after the transformation shown on the grid, and you need to identify what transformation has occurred. And so you need to know what to look for with each transformation type. The first one is a translation, which is a slide across the grid. And it looks literally like you've slid or moved your shape somewhere across the coordinate grid. It does not flip directions. It does not turn on its side. So if the shape looks exactly the same as it originally did, but it's just on a different part of the grid, that is a translation. Next is a reflection or a flip. This will be when the shape is flipped over a line of reflection. Like in this case, the y-axis is our line of reflection. This triangle is flipped and facing the other direction because it has been mirrored over that line of symmetry or that line of reflection. And so if you notice that the shape is facing the other direction but looks exactly the same, and you can identify a line that it has probably been reflected over, that will be your reflection. Then we have a rotation. Rotation is a turn of a certain number of degrees. And so if you can tell that the shape has been turned onto its side by either 90 degrees, 180 degrees, 270 degrees, those are our typical rotations usually, then we know that a rotation has occurred. And then lastly, dilation. That is when you enlarge or reduce the shape. So this you will notice because the size has changed. And so if the shape has been enlarged by a certain scale factor of something larger than 1, like double the size or triple the size, or if your shape has shrunk by a certain scale factor like half or third or a fourth, a dilation has occurred. The only other one you might see on a grid is a glide reflection, which is a translation followed by a reflection. So if it looks like the shape has been slid and then flipped over a line of reflection, that would be a glide reflection, the combo of translation and reflection. I hope this helped.